Captain Roger Woods, ele soma acima de 7.500 horas, já atuou em várias funções, sempre relacionadas a operações de voo e instrução, e sempre, como não, relacionadas a safety, porque não existe quem trabalhe com operações de voo e instrução que não esteja trabalhando com safety, com segurança de voo também. Então, o Captain Roger Wood, ele foi participante do exército UK Army, do exército britânico, como instrutor, uma especialização em Night Vision Goggles, operação noturna, trabalhando com CRM, ambiente FAA e EASA, certificado em ambos. Trabalhou também a função, atividades na Augusta Westland como chefe de instrutor-chefe e na produção. E tem uma característica, que eu até falei para ele que ia falar. Ele tem aqui, eu não vou ler porque ele foi instrutor de vários modelos. Ao invés de eu citar um a um, vamos dizer assim, ele voa todos, ele voa toda a família. E ele tem uma característica assim, special clearance to perform helicopters mountain rescues above 14,500 feet. Ele tem treinamento para fazer operação de salvamento em áreas acima de 14.500 pés. Isso não é uma coisa muito comum para nós aqui no Brasil. Mas eu gostaria só de dizer uma coisa. Nós somos pilotos e pilotos não são pessoas comuns mesmo. Nós somos diferentes. E ele tem uma diferençazinha a mais. Então nós somos diferentes mesmo. Goste ou não goste os estranhos da aviação. Nós somos diferentes porque nós voamos. Captain Roger Wood, please.
Thank you, Captain Grant. Thank you very much. Yeah, well, I hope not. Unless technology fails me, then I will need it. Thank you for the AWPC, I hope I said that correctly, community for the invite to come and talk today to you. And really I'm going to talk about technology, of course, because that's what we're interested in, and the safety aspect. But yeah, I did do mountain rescues above 14,500 feet, Mount Kenya. So not just anywhere, but somewhere that was particularly warm. In fact, warm's not correct, it was damn hot. And that was tested. I used to fly in Arctic Norway as well and do some rescues there, so some extremes. But I'm here today to talk to you about technology and safety and really the way forward, and look at new technology. Some you may have seen. I think certainly one that you probably haven't, so we're going to work our way through. And to start things off, I'm going to look at an accident, a couple of accidents actually, because as much as we might not like them, and I'm going to tell you already, this accident and the later accident I'm going to show you, there were 7 fatalities. This one in a 76B, and you're probably all looking saying, well, 1996, that's a long way ago, why can that can't be new technology. Well, it was to do with technology 100%. Well, there were other factors, but it was a big factor for sure. And the reason I'm looking at this incident is 8 years later, the very same company had another accident not using technology or using it incorrectly in an AW139. So a little bit of history on this particular accident. This is actually in Ireland. North of here is Belfast, where the international airport was. And the owner of this aircraft was a rich lord. He loved aviation and he wanted helicopters and he wanted to be able to fly in any weather. Okay, not icing, but he really wanted to be able to fly IFR. So he made sure that his crew, as best as he could, were qualified. He flew 2 pilots and he wanted them trained. And on this particular occasion, this area here called Balwan was where he lived. Thanks for the lights. Was where he lived. And on the morning of this crash, the chief pilot, who had in excess of 11,000 hours, and the other pilot for the company, who had more than 4,500 hours, took the aircraft from Bal and they went up to Aldergrove where they landed. They picked up a guest pilot from the Irish authority. He had more than 12,000 hours. So between them, very nearly 30,000 flying hours. And the 2 senior guys there were both very well trained on instruments. The other pilot, with the slightly less hours, 4,500 if you want to call it that, he had actually failed an instrument check just a few months before. So the idea of the flight was they went up to Belfast, they landed, the chief pilot got off, the guest pilot got on board in the left seat, and they went out and trained for 1 hour. They landed back at Aldergrove, the chief pilot came out, and the pilot for the company, the guy with the 4,500 hours, said to the guest pilot, "You can stay up front, the boss will get in the back." And so he did that, and he was on the communication. The company pilot then went a bit further. He said, "Hey, why don't you fly us back? Fly us back to Bow 1. So now this guest pilot, he'd done some 76 time, but not a great deal. He was an instrument examiner, and they flew back down this route. This is the last part of the route here. And this route is a GPS route. It wasn't cleared with the authority, it wasn't surveyed. It was just a route written on a chart by probably the chief pilot. And what the procedure did was it came to this point, then came down, and they descended to 1,500 feet in this area here, called Warren Point. And then the final turn on heading 132, or course 132, because it was a GPS route, they were going to descend to 500 feet to the missed approach point. Oh, let me go back a bit. Well, my apologies there. To the missed approach point. And if they became visual, they weren't going to go into the boss's house. That was the procedure. Not cleared, not surveyed. So on the day, after that initial training flight, the crew returned. But now, the guest pilot was flying from the left-hand seat. And the company pilot, the one that didn't have the instrument rating, was in the right seat, and he was acting as aircraft commander. And they flew down the route. Here's the last part. These are the internal messages. The pink is the guest pilot, the green is the company pilot. He was non-handling pilot, and the chief instructor didn't make any calls, although he was on the live intercom, and he wasn't concerned at all. Well, let me tell you what happened. This is the route that the GPS wanted to take them. They didn't want to do that. As they approached Warren Point, and the cloud base was about 1,000 feet, maybe a little bit below that. It was at 6 o'clock at night, so it was dark. The company pilot said, "Oh, there's Warren Point." He could see it below them. They flew directly over it. And the reason they flew directly over it was prior to that, somewhere up here, the aircraft was on altitude and nav mode, fully coupled. And the guest pilot was happy flying that way, but the company pilot said, you want to keep flying straight on, keep going 180, because it'll want to turn you early, and you don't want to do that. So he took it off nav and he put it on heading, and the aircraft kept flying straight over Warren Point. And at that point, the company pilot said, "Oh, there's Warren Point. You can descend to 500 feet now." So they started to descend to 500 feet. They then decided it was a good time to start the pre-landing checks. So they went through the order: gear down, gears down, T's and P's in the green. They went through the list. And the final instruction was, fuel's okay, and then the company pilot said, "You can turn on to heading 130 now." The trouble was, the aircraft was about here when he made that call. And they just about got on heading 130 when they hit the hill, this area here, which is about 2,000 feet, at 120 knots. Well, there wasn't much left of that helicopter, and of course the crew did not survive, three fatalities. What I want to show you here is, well, we jumped a couple, but let's go to the first one. This is the CDI. Of course, in nav mode, it's automatic, and the actual heading was 132. Well, as they approached that predictive turn point that the GPS wanted to do, they were, of course, left of track. Instead, they kept flying on heading mode. When they got to Warren Point, of course, it was direct, and those of you instrument rated here will easily see what's happening. By the time they reached the point at which the non-handling pilot, that company pilot, said, "You can turn on heading 130 now," the CDI looked like this. It was about half a dot. They were half a dot right of track. Now, those of you who fly ILS here, you say, well, half a dot right of track is actually, I mean, we'd all like to be on the track, wouldn't we? Let's be honest. But half a dot right of track would be a pass on an instrument check. When you came out the bottom, the runway would be just to your left. Well, this isn't an ILS, this is GPS. And the problem is, They were 1.36 nautical miles right of track, and they had no idea that they were there. And the end result, of course, as I mentioned earlier, there were 3 fatalities. Purely for the misuse of GPS technology. And I'm going to talk about some of the advances in technology in a moment. But you have to understand, that's rule number 1, you have to understand the technology you're using, what it should be used for, what it shouldn't be used for, and what its limitations are, basically. So, they were unlucky. They came up with a plan, it wasn't a good plan, they used it incorrectly, but ultimately, it wasn't their day. Some people are lucky, and probably don't deserve to be. Can you run that video for me, please? Thanks. So, I'm going to show you a video here. This is a fixed-wing video, but it kind of highlights the point a little bit. That's great, thank you. Some of you may have seen this before, some may not. So here we go. This is inside a beach barren. There's 4 people, there's 2 passengers facing rearward, they have no idea what's happening, and then 2 crew who, frankly, probably shouldn't have pilot's licenses. At the front, just in this bottom corner here, you'll see in a moment the ground come alarmingly close, some trees. Just watch it, just like that bottom right-hand corner. There it goes. Pretty close. We'll look at it again. Slow motion. What I want you to pay attention for is here is a handheld GPS. That's what they're using for guidance. There's the ground in a minute, just going to come by. Pretty close. We'll slow down a bit more. Now pay a little bit more attention. When you see the ground come into view, I want you to look in the bottom right-hand corner of the screen. So here's the handheld GPS they're using for navigation. Ground's going to come up in the corner a minute, and I want you to look down here. Right in this bottom corner, just after the ground. Keep looking, there's the ground. Look in this corner, look down here. There. That's the guy's cell phone. And let me give you a little bit more information. This aircraft was flying in excess of 150 knots. And could you see anything out the front? Because I couldn't. 150 knots, handheld GPS, completely oblivious. Well, how close do they get? There's the wing they hit. And there's the leading edge. Probably a branch maybe as thick as my little finger. That was a pretty lucky day, isn't it? And they were probably way more negligent than the first crew. They lucked out. Now I'm going to move forward to March of 2014, so just last year, and this is the same company, it's the same owner. Now let me give you a bit of information on this owner. I've already said that he really wanted to fly in any condition. So after buying a few different helicopters, he went out and he bought an AW139. Now I know we have different operators here, people fly different aircraft, but the AW139, I'm telling you, is a phenomenal helicopter. The power available in that helicopter is unbelievable. The systems on board, in IFR, you find it hard to beat. 4-axis autopilot. This particular helicopter had auto hover. It also had a forward-looking IR camera, which wasn't switched on, but it did have it. Really capable. The crew, the aircraft commander, was, I think he had about 3,500 hours. He was instrument rated. He had 500 hours, I think, on type. The co-pilot, 1,200 hours, I believe, and 300 or so on type. Both instrument rated, both very capable. On board on this particular occasion was the Lord himself and another guest. This is his grounds now in UK. This is his helipad, his house is here. Big open field and fields beyond it. Quite a clear air, actually. Other than the trees, there weren't really any other obstructions. Well, the weather wasn't like that on the day they took off. It was actually a little bit more like this. Well, this was just after the crash. It was thick fog. Probably 100 feet in fog. That's how bad the weather was. This crew, there were 2 pilots, but they weren't operating in a multi-pilot capacity. And that is evident in the commander's brief. Because the commander briefed the following. He said to the co-pilot, right, all I'm going to do is I'm going to take off, go to the center of the field. I'm just going to pull power. We'll go straight up. I'll put on the strobes. And if you would just send to the heading book, if you wouldn't mind. That was his brief. In about 100, less than 100 feet probably of visibility. That was the brief. Well, let's have a look at the area in a little bit more detail. This is the house, here's the helipad, the center of the field. So he did what he said, he went to the center of the field and he took off. But when he took off, 139 has about a 5 degrees nose up attitude. So he started to go up, but shortly after he started to go up, he actually went to about a level pitch, maybe even a 1 degree down. But of course the aircraft is still climbing, but it's now moving forward. And he approached this tree line. The trees are about 75 feet, and the aircraft got a maximum height of 120 feet. Well, he was clearly IMC at this point. We only had to look at the slide before with the weather. Well, a strange command came out of the co-pilot, because what he said was nose down. And I don't know, a lot of you here operate with 2 pilots on board. 2 pilots isn't multi-crew, by the way. You need to be trained for multi-crew. And those of you who are multi-crew will know that nose down is not a command. It's not a call that anyone would make. And it was very confusing to this pilot, I'm sure. Now, the aircraft, as I said, is a phenomenal aircraft. This had auto-hover, so although not legal to do so, they could have gone auto-hover, pushed the go-around button, and the aircraft would by itself have transitioned up. On heading, climbed and accelerated to VY, which is 80 knots, up to a minimum of 200 feet, higher if they selected, and they would be here today, and I wouldn't be talking about it. V-Mini, the minimum speed for instrument flying for the 139 is 50 knots, because those of you who fly instruments will know that in a helicopter we don't want to be too low speed. They're not the most stable thing at 30 knots IMC. It's a little bit difficult to know what's happening. And that's why manufacturers, all manufacturers, Bell, Sikorsky, Airbus Industries, and Augusta as well, we have a V-Mini speed. But they went past V-Mini, they were getting up to 50 and 60 knots, and they could have pressed the go-round button now and the aircraft would have gone in a normal go-round mode. But they didn't do that either. But this call was particularly confusing, because what happened at the same time is up this road, there was a car coming towards them with his lights on. And I don't know how many of you, maybe some of the things that Harry was talking about, there's human factors. But one of the human factors is that if you see lights coming towards you and they go below you, and you go over the top, you get this pitch up. Subconscious, you think you've pitched up. And it's a very real feeling. So that's maybe what the crew suffered, and the co-pilot did. Well, he told the pilot to pitch down, he pitched a little bit, and now the aircraft's accelerating. Well, if you've got no reference, what happens if you accelerate? You think you're pitching up as well. So he followed it with another call of nose down. Well, the pilot pitched nose down all right, he pitched 35 degrees nose down. 35 degrees at barely 100 feet in fog, and about 50 or 60 knots. Well, the aircraft went down to earth pretty quickly, and even the emergency EPWS, which recorded all of this, it was too late for it to try and give the collective pull-up, which the 139 is fitted with. But 35 degrees nose down is steep. He probably saw the ground a little late, and he reduced that pitch to 25 degrees, but the end result was this. The aircraft impacted on the heading. And we know it's on heading, which means the pilot probably didn't have his feet on the pedals. So the actual yaw trim was what kept them straight. They had engaged heading mode, but the pilot had pushed the force trim release. So now he's manually flying in pitch and roll. And they had not selected an altitude. So things weren't going too good. The aircraft head here, it actually span on its belly, 540 degrees, and ended up facing back the way they came. And unfortunately, as you could probably guess, they were all killed, 4 fatalities. And one of the things here that, besides the lack of use of the automation that was there, the new technology, there's also GPS error in both of these crashes, actually. The first one's very easy to see. I don't think there can be any doubt about that. But the second one, some of you are probably thinking, well, where's the GPS thing? Well, I'll tell you where it is. What they were planning to do, they were taking off in fog. They were going to fly a GPS route after that. So if they hadn't had that capability, then why would they have taken off? So GPS was an element that made them, made that decision for them. The other part is that, and I know these type of approaches are coming to Brazil. I believe there's RNAV approaches or LNAV approaches now, a couple of airports, certainly one up at Rio. There's a precision approach there. I know, because I looked the other day, last night in fact. But this lord, for about $100,000, he could have had a approach surveyed into his helipad. And not just any approach, a precision approach. An LPV approach, most likely. Some of you may not have heard of that, I'll speak about it in a moment. And part of that approach would have been a missed approach, and he could have had surveys, a departure as well. So imagine in the crew now, because in UK, the rule says if you're private flying out a helipad, you need visual references to take off. And that's what they thought they had. If you're at an airport, there are limitations. If you're on a published procedure, there are limitations. They would not have been allowed to take off. Had it just been good enough that they could have taken off, they would have been in the mindset of IFR. I don't know how many people here fly fixed wing. I've got a bit of a fixed wing background, a little bit of jet work, turboprops. And I can tell you that most guys flying, as I did a Hawker XP and the like, your mindset, even on a clear day, is you're flying IFR. It's an IFR departure, routing, and arrival. And if you change from that, then great, oh, I'll do the visual. But that's the mindset. And that's probably the mindset of offshore operators in helicopters. But it's not the mindset of most of us guys who operate VIP or emergency helicopters. We want to fly visually first. And we need to change that mindset a little bit of thinking the IFR route first and then degrading it or downgrading it to VFR if the conditions allow us. So GPS is definitely an area. They were flying in non-precision area here. Minimum's down to 400. Not as accurate as you think it is. What's coming in the world, and has been for a while, is GBAS, Ground-Based Augmentation System. And that allows us to do these WAS approaches. This approach here, this LNAV, is what's up in Rio. There's a couple of approaches there. Is it RDU, the airport? Something like that. Am I correct? One of the airports up there. What we're using in America through Europe now is LPV approaches. And they are basically down to 200 feet. It's just as good as an ILS and way easier to fly, and I'll show you that in a moment. This type of system will bring you all the way to auto land. And I think Rio International was looking at that a few years ago. Maybe they scrapped the idea, but it's certainly out there, and WAS system, ground-based augmentation, is coming. Well, can you play that video? Thanks. It's coming to us all. And we really need to push for it. This is a LPV approach in a AW139. You can see at the top in white, just up here, it says VGP. Now the beauty of an LPV approach is this, or any precision GPS approach, is unlike ILS, we have to tune the frequency, you have to identify it, you have to turn in the inbound course, you have to get the markers. It's a lot of work to do. Even if you guys flying the really superb, I have to say, brand new, that system's 4-axis autopilot, it's really good. You can put it in preview mode and have all that information, but you still got to do the work. Well, here, you don't have to. You put in the GPS route, and at the end of the route, if you suddenly decide you want to do approach, you push the approaches available, select the one you want, you enter it into the system, and that's all the work you have to do other than monitoring. How easy could it be? Because the system works in itself, it keeps checking. So here oh, that's my bad. Sorry, can you play that again? And just fast forward it a little bit. Finger trouble, technology. Great stuff. Don't you love it? Yeah, just take it to about 1.5 minutes. No, yeah, about 1.5 minutes. No, 1 minute 30. Go back. Go back. Yeah, there, that's good. Okay, so here it is now. Actually, the VGP is armed, and what that means is it has an RMP of 0.3 or less. So the system's checking on itself. And it won't allow the aircraft to descend, and because VGP is armed, the aircraft's descending. And it's not even on the final course yet. So you can do curved approaches. So this aircraft's now waiting for LPV to be armed, making sure it comes into the correct parameters all the time, checking that it has the correct information from the GPS so they can start its final turn. There we go. LPV is armed. Now we've got NLOC and NGS. Pilots out here who fly the Grand New, the SP, will maybe have seen this in training, and maybe if you've flown up to Rio or some of the 1 or 2 airports in Brazil at the moment, hopefully going to get more. The aircraft's then going to fly that GPS approach, localizer and glide path, all the way down to the same minimas as an ILS. So LPV is the way to go. That's the technology to go for, and eventually, less than that, auto lands, which a way to go in helicopters yet. But what's the advantage of an LPV approach? Well, it has localizer performance. It's same integrity as an ILS, take it down to 200 feet for us in our normal helicopter daily work. It's fully flexible. We've tested in the AW139, 9 degrees angle. Going back to the Lord's crash last year, he probably could have got a 5 degree down to maybe 250, 300 feet into his own helipad with a missed procedure. How good is that? You can do the curved approaches as mentioned. You get the go-round. Of course, it's all in the database, as you would expect it to be. And it's customizable. Use it for offshore. Helipad to a hospital. Helipad in a field. Wherever you want. As I said, curved. And the last thing, the most important to me, is it's really easy to use. It's literally a couple of pushes of a button, monitor the system, and everything's done for you. All that tuning and identifying, and you've got the wrong frequency, and you've got the wrong inbound course, all taken care of. Technology. Well, we're looking to go a little bit further than that, because what we want to do is look at low-level IFR routes. What's that? Well, let's think of why. The background. Well, first of all, helicopters, yes, I went to 14,000 feet, a little bit, but I certainly didn't fly up there for, an hour or more, 30 minutes or less, of course. But we don't have pressurization. Most helicopters don't have icing, and it does get colder the higher you go. Here's one that most people don't think about. The recommendation for most emergency trauma victims is to keep them below 3,000 feet AGL from where they took off from. And of course then the safety. We do fly low level. And that means we're getting pretty close to the ground. And in marginal weather conditions, it's not good. And those of you who've been in marginal weather, or even in a vert IFC, maybe someone's done that here, or got close to it, it sure isn't a good feeling. And of course it's noisy. So, IFR routes. Well, this is one in Italy. Now in Italy, controlled airspace starts at 8,000 feet, so the first usable flight level is flight level 90. So the aircraft are all up at 90 or above, and the helicopters have a special route from Torino at 3,000 feet. So what do? They do a GPS departure, an IFR route, and an LPV letdown. That's safety is best, if you ask me, if you're correctly trained and qualified. Now, I listened to the air traffic briefs yesterday from the Colonel, and I know there are interesting factors around here, especially in São Paulo, but, and I don't know the area that well, but an IFR route from here to Rio, I don't know. It's about an hour and a bit, hour and a half, something like that. Yeah. So you get a climb out of here. I understand that every helipad, and I was counting the other day, and I don't know where I got to, but it was a ridiculous amount here in São Paulo. It really is. It's impressive, actually. So you couldn't all have those instrument departures, but you could definitely get entry points where you could get a climb speaking to the controller and get into controlled airspace, helicopter-controlled airspace, and fly nice and safely with no other airplanes around, IFR down to Rio, and then get a similar letdown in Rio. It's something to work at. It's just my opinion there. So what else do we have besides that? Well, of course, a lot of you are used to H-tours. You're used to enhanced ground proximity. SBS. Who's flown SBS? I love SBS. Synthetic vision, like you see in the brand new, the 169, 189. It's tremendous. I love it. I really do. And you get wonderful things on it like Highway in the Sky. So let's just have a video. Can you play that for me? I'll try not to push the wrong button. So here's SBS. This is on the Garmin 1000. We have fitted to the Koala. And some of you are looking at this go, oh, there's way too much information for me. Well, let's talk about that in a moment. Let's just see what the benefits are. Well, of course, there they're flying down the coastline you just before. Here's the mountains. We're going to see the SBS view on it. Red, it's going to say more closer than 500, or depending on the setting. Here's the obstacles, you get the warning, you'll listen to everything. This little fella in the middle, flight path trajectory, this one. Wherever that points is where you go. He's going right on that runway, there. I got a guy once and put it on the horizon, exactly split it. I covered the tape on the altitude and made him bank right to 60 degrees, back left to 60 degrees, and straight back on heading. We took the tape off, and this is not a lie, it was 10 feet, maybe 11. So we see with the rapid descent here, the terrain's changing, he's getting a warning, flight path trajectory still, and all the information's there. Here's an ILS flying through the HITS, the highway in the sky. And if you're flying on that dot and there's no red ground in front of you, well, in theory, you're not going to hit anything. But it's not cleared for terrain flying. You're not allowed to use SVS with a TORS input, an obstacle database input, to purposely fly around obstacles. But if you go, and this is a GPS approach, if you go in a vert IMC, or you're in a situation you got yourself into that you'd rather not be in, can you use it? Absolutely. It's not something you've got to tune, you've got to set up. It's there for you, and it's going to give you immediate information. Now, I know some guys, and I'm the wrong side of 50 as well, and they look at that and go, there's just too much information. How can I take on board all of that information? Well, let's think back a little bit. To the guys who were like me, the wrong side of 50. When you started flying, you were looking at instruments, you're looking at the artificial horizon, attitude indicators. And what was your instrument scan? It was look at the center instrument, then look at rate of climb. Look at the center instrument, look at your compass. Look at the center instrument on wings level, look at the altitude. Look at the center instrument, look at the turn or slip. Look at the center instrument, look at the temperatures and pressures. That's how you built up your scan, correct? Well, this is no different. You're just looking, when you first see it, and trying to see everything. Well, what happened when you first started flying? You did that scan. And most people, I know I did, what happens after a little while as you get more used to the aircraft, your kind of horizons broaden, and you start seeing all of those instruments. Your eyes are still moving around, but you're picking up that the altitude's gone up and the speed's gone down, and you do an instant correction. Because you're building confidence and knowledge and skill set within those old instruments. What happens with SVS and new technologies, synthetic vision as I just mentioned, and glass cockpits in general, is people look at everything and they say there's too much information. Well, you need to be trained by someone who understands the system to identify what you should be looking at within that display for what you're trying to achieve. And then, after a period of use, you will then start to see the whole picture. Don't expect to see everything all at once, because you sure didn't do that when you first started doing instrument training. I looked in we went up to, Danielle took me to one of the heliports, very impressive. I know, something like 70 or 80 helicopters in there. And there was an old 199A model there. And I looked at the panel in that. And a lot of instruments. A lot of instruments. It's the same thing, it's just shown to you differently, and you need to learn what to look at and when to do so. So lastly, let's talk about some other things. Helipads. Helipad lighting. This is an offshore rig. It's pretty good. Got some lights around it. But be honest, this is the same one. Would you rather land on that one or the one before it? I know where I'd like to go. So we need to encourage the end game. When we're landing, we've done all this approach and then we've got a rubbish helipad to land on. So we need to make sure they're lit. And it's not a huge amount of money in the bigger picture of things. So development in helipad lighting. TCAS 2, it's fabulous. And of course it gets shown on the SVS. I did have a video, I don't want to run too much at a time. I'll only be about an hour over, is that okay? No, I won't. So TCAS 2, this is in an AW139 here, and the video will actually show this contact coming in from 150, getting close to the 139 on the trial. The aircraft immediately gave a green climb indication and a warning, and obviously in the ear as well. You pull the collective, you meet the climb. It's a bit difficult, a bit fuzzy here, but this says -400, and by the time it passes underneath, it'll at least be 500 or more. The later video shows another contact coming in, getting to about a mile, and then turning off to the west, and the system doesn't alert you. It's a fabulous, fabulous system. And I know it's annoying. And who was it? I think it was the Colonel said people turning off their transponders. Wow. Well, that's a problem, isn't it? I know it's annoying, especially in busy airspace like around Sao Paulo, but trust me, when it warned you of something you didn't see and it was really close, you'll be thankful you had it. The fly-out mode I mentioned, in our latest product, the 139, which has been around for a while of course, but it's a tremendous helicopter, the 169, which I'm really looking forward to, the 189, anything with 4 axes has this mode. So if you're flying along to ground that's slightly raised, and you just click the top, well first of all you're probably going to get a gear call, but if the gear is up and the helicopter thinks you're getting too close, it will automatically, even though you're in an altitude hold mode, pull the collective in and start giving you a climb up. It'll also do it if you take off with the gear down and then start descending back to the runway. Maybe you lost sight like these guys did in the 139, it will give you a collective climb. The only problem for those guys is they didn't do that kind of gradual descend. I mean, if you pitch 35 degrees nose down, there's not many systems that can recover that for you. Last one, who's heard of this? Anyone? Anybody at all? Daniel, you can't put your hand up. Anyone? No? Okay, another clue. What about this? Alright, let's show a video. You play this? Opals, or lidars, is an area we're looking into. And what you'll see here is a nice shot of an Augusta 139 flying towards a mountain. This one's on search and rescue. Now the system's on all the time. We'll show it coming on, but it's on all the time. And it sends a laser out from the rotor disc and starts picking up where the terrain is very accurately. You start seeing a reading here, 12 meters, 10 meters, going down all the time to 0.1 of a meter or less. And eventually, we haven't got the audio, we should play the audio on this one. But now it's going beep, 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 beep in your ear. All right? There it is. Okay? Now, what's the other use? We don't all do search and rescue. Well, here's a helicopter landing on a road. Could be the helipad of the boss. Again, system's on all the time. As it starts to land on the road here, again, once you get within a certain range, it'll bring up the screen, and if you get too close, it's going to start bringing up that noise in your ear. Beep, beep, beep. This one doesn't get close enough. Let's think of another use. How many aircraft accidents happen when you're taxiing and you hit the hangar, or you hit another aircraft? Well, here's one taxiing, there's the hangar. Again, the system's active, starting to warn you. I was actually, and he taxis forward and there's another aircraft there as well. I was actually in Florida a couple of years ago, and the guys were telling me, I was teaching on 109E, and the helicopter pilots there, they were saying, oh, there was a bit of an accident a few days ago. And I said, well, what happened? He said, well, an Army Black Hawk landed, and it was taxiing in at night, and it taxied straight into the rotor blades, hit the wingtip of a G5. And I went, oh. That was a little bit expensive. This would have saved that, of course, hopefully. So, here's an A109. Sorry, this is a koala. Beg your pardon. You think I know, wouldn't you by now? Sorry. So there's a koala. There's the A109. I knew it was there somewhere. And that's what I'm saying. There's a busy cockpit. Then we made advances. Where are we gone? Well, this is the koala with a Garmin 1000 fit. We're looking at an autopilot fit to the koala. Really great system. Fabulous system. I love this particular aircraft. There's the new Trekker. This is slightly changed now. We're going to go with the Cheltenham, but same size displays. But look at the indications here on this synthetic vision. And I know Harry from Bell, we probably disagree a little bit here because our view in Augusta Westland is not to put on this type of displays the old instrument look. That's not where we're going. We're putting synthetic vision. Now, having said that, a lot of the aircraft, you can actually revert this back to the old look if you want to. So you do have that option. But we're going this way. Why? Well, what's the leader in technology these days? Is it the helicopter industry or is it the bizjet world? Well, it's the bizjet world. Because you've got an impressive amount of helicopters here in Sao Paulo, but you go in most airports around the world, you'll see 4 or 5 helicopters and 30 business jets. So where did SVS come in? Business jets. Where does TORS come in? business jet, we change it to HTORs. TCAS 2, business jets. Head-up displays, business jets. And business jets put this in the front of their aircraft for situational awareness, to try and help us, the pilots. Good, I've only got 5 minutes to go. AW139, great aircraft. My favorite, and I can't wait to get on this aircraft, the 169. This is going to be a great helicopter. Deceptively big, really big on the inside, a bit like, was it that program Doctor Who, TARDIS. Big on the inside and doesn't look so big on the outside. It's a really great aircraft. Of course, you can have one of the engines running, run all the systems without the rotors going. Fabulous. Been flying the 189 now for quite a few months, well, year and a bit. If you have an emergency with the 189, what will happen up here is it'll stay on the page, but it'll highlight the emergency page. You just push the button and the page comes up. Hydraulics, whatever it might be. So technology, is it help or hindrance? I told you it wasn't going to be long. Well, of course it's great. Absolutely. Bad technology is not good. And if you use technology incorrectly, that's not good. We tend to focus on the benefits of technology and we forget what it should be used for. And of course, there is a cost factor. And to finish with, I just want to tell you one little story. Only take a couple of seconds. Technology for you. I was in Europe a little while ago and I called back to my wife. She's a highly intelligent lady, way more intelligent than I am. And I could hear this noise, a bit like that laser we just saw. I could hear beep, 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 beep. And I said, honey, what are you doing? You're reversing the car, aren't you? And she said, yeah, I'm reversing into the garage. And then I heard beep. I said, well, I'm glad you've stopped. And she said, well, I have. Can I ask you something? Did you look behind you when you reversed? And she said, no. I said, well, why not? She said, well, that's what the reverse thing's for, is to tell me when to stop. I said, no, it's not there to tell you when to stop. It's as a backup. She said, no, every time I get out and I have a look, I'm always 1 foot away from the wall. It works perfectly. Well, we had a discussion a little bit further and I realized I wasn't going to win and I wanted my dinner, so I accepted that. Of course, later the car industry has developed automatic parking devices, but that's not what that one was designed for. So my end bit of information to everybody is please enhance technology. Use it, but use it correctly for what it's there for. We will develop better systems, we'll bring that LiDAR into the tours maybe and make that much better system as well. But use it what it's designed for. Thanks very much.
A palestra do Roger é Can New Technology Improve Safety? Pode as novas tecnologias melhorar o safety? E uma questão assim rápida, existem 2 correntes hoje a respeito de novas tecnologias. Uma de um fabricante, eu não vou dizer quem é, tá? Uma de um grande fabricante europeu de aeronaves de grande porte e outra de um grande fabricante americano. Então são 2 correntes. Uma prega que nós devemos elevar a tecnologia aos limites para que nenhum erro humano possa ser possível. Essa é a europeia. E outra americana que diz o seguinte, sempre vai ficar o piloto como a última palavra. Mas eu simplifiquei um pouco, mas mais ou menos assim. Uma corrente prega que o design dos aviões seja feito de tal forma que os computadores tenham a palavra final. E a outra corrente diz o seguinte, os computadores não, o piloto tem a palavra final. Eu gostaria de saber a tua opinião a respeito dessas 2 correntes. You understand?
Yes, yeah, I do get the question, thank you. I wonder what those manufacturers, I wonder who it is you're talking of. Try this. Yeah, it is a great, I'm really loud, there we go. It is a great question, and yes, I kind of answered that from a possible European manufacturer's view, whoever that may be, that we really want to look at automation and enhance it. But at no point, I don't think anyone in a certain European manufacturer has said that we want to take all of the control from helicopter pilots. That's not the case. what we want to do is really minimize as best as we can by giving the pilots everything available. Ultimately, you can push a button and turn it all off. But most of the time, and I hate to tell all the pilots here, ladies and gentlemen, but for the most part, technology actually flies the aircraft better than we do. And I'm sorry, but that's the truth. And you might not like that, but it is the truth. And it reminds me of an accident in a country just a little bit north from here, where there was an issue with the aircraft, high temperature one of the engines. They put it to idle. They were up at about 12,000 feet, fully automated, IMC. They were flying a VFR route, so they shouldn't have been IMC. The first thing that pilot did, instead of pushing up one button that would have said nearest ILS, selecting the nearest ILS, which was only 10 minutes away, waiting for a second and just taking the frequency, putting it in the ILS frequency, and then press activate. And then all he had to do is on the heading bug, steer the aircraft on an intercept and push approach. Well, they're not with us today because what the pilot did was disengaged all the upper commands, could see what was below him and tried to descend into the mountain. And tried to come eventually to a hover on one engine at about 11 and a bit thousand feet. If he'd have left it on automation, he would be here. Now, I'm not saying that automation is the answer to everything. We need to maintain, certainly in the foreseeable future, the ability to disengage all of that. Even a drone has someone controlling it. But we need to develop it a little bit like the airline pilot, and I'm sorry to say this, we needed to backtrack a little bit into system managers. Take off, fly in good weather, but when the weather's not so good, when there's an emergency, give the control of that aircraft, if you can, to the aircraft systems. And I know some people might not agree with that, but for the majority of time, the aircraft will fly that better than you. And we saw the video of the guy in the 350. If he had had a forward-axis autopilot, it might have been less exciting. When I'm in the simulator and someone gives me an unusual attitude, in the 139, I quickly look what the parameters are, because I know the limits of the autopilot, and I go, oh, go around. Aircraft, don't climb. And the instructor in the back says, you're not allowed to do that. Why can't I do that? So I think the company that I work for, we're really trying to make bounds in technology, but we will never take that command away from the pilot. That is not true. Ultimately, if that system fails, and you recognize that, then you need to step in.
Ok, thank you, Captain. Alguém mais? Carlinhos.
A respeito da proficiência do piloto, com o acesso de automatização na cabine, nós vimos aí o acidente da Air France, que foi uma falta, eles não conseguiram perceber o que aconteceu durante o voo, porque estavam muito acostumados ou treinados para voar somente no automatismo. Não conseguiram reconhecer que tinha alguma coisa errada. Reconheciam que tinha alguma coisa errada, mas não sabiam o que, na verdade. Veja isso um paralelo. Eu voei o 109 SP por 5 anos. E nós temos também um Power. E agora só estou voando Power. Realmente é uma... como eu poderia dizer, é uma diferença muito grande do tipo de voo automatizado como tem no SP e do Power. A carga de trabalho para o piloto no Power é muito maior do que era para o SP. Então a questão é, o automatismo, a pessoa voando sempre usando o automatismo da aeronave, ele, no caso de uma emergência, ele vai reconhecer o treinamento nesse ponto, eu acho que seria o mais importante a respeito, não é?
Yeah. I mean, obviously, like I said, with the scan of instruments, it's a similar thing. You have to build up the skill set, like early instruments, looking at the individual ones and building up a bigger picture. But you kind of hit the expression we say in the UK, the nail on the head. There are going to be emergencies. Of course, it's annoying, I'm talking to myself in Portuguese. There are emergencies. Gave me time to think as well. there are emergencies where something so strange, as in the Air France and other issues, that the pilots are completely confused. And that's why I'm saying we can't take everything away. But what I would argue back about that is, as rare as that incident is, how many instances has automation, or could have automation, saved lives by sticking with it? It far outweighs the really unusual ones. Now we can't, unfortunately, I don't think, ever get rid of the odd anomaly that will happen with automation, especially as we develop more automation, that we'll be able to get rid of it all. We just won't. There are going to be times when pilots, drivers of complex cars, trains, ships, whatever, any technology, an iPhone for instance, we're just like, I look at my computer sometimes, I have no idea what it's doing. And that's going to happen to us. But that leading to a fatality or a bad accident is far rarer than us trying to take over a situation and not allowing the system to continue what it was doing. You saw in the first crash, they just had to leave the aircraft to do what it is. What we need to do is build up a skill set to understand when we should intervene and when we shouldn't. And I think when we should is way less than when we should intervene is way less than when we should. I think that's the point I would strongly like to put across.
Se me permite, só para completar o acidente do Air France, me desculpem entrar assim, mas aquele acidente do Air France, nós mudamos todo o nosso treinamento, eu do simulador de Boeing, nós mudamos todo o nosso treinamento, eu digo, a Boeing mudou, a Airbus mudou e outros fabricantes mudaram todo o treinamento de stall, pré-stall, stall em altitude, tudo, nós mudamos todo o nosso treinamento em função daquele acidente. Nós, da forma como nós treinávamos características de stalls, a baixa altura, em altitude, várias características em curva ou não, todo o treinamento mundial foi mudado, nós treinamos de forma diferente hoje em função daquele acidente. Naquele acidente, desafortunadamente, os pilotos não entenderam o que estava acontecendo. Eles bateram lá na água sem entender o que estava acontecendo. O comandante que chegou na cabine em seguida, eram dois pilotos mais novos, ele tentou entender, mas a poucos segundos do crash. Então, mas aquele acidente levou a uma mudança total nas características de treinamento de stall, nas aeronaves de grande porte. Desculpa eu interferir aí, mas aconteceu isso realmente.
Just one thing I want to add, that one thing we do as a manufacturer, with our 139 simulators, the one in Whitby and the one in Italy, we take any real information. We know that in Brazil there was an incident with tail rotor on a 139. We take that information. We might not like it, but we take that information and we feed that into our simulators. So that simulator is as close to the real aircraft as it can be. Now, we know it's very difficult to get all the way there, same as fixed wing, but we get that information, every bit that we can get, and we put it in the simulator. We don't just guess, we try and use real information as best as we can. And I don't want any accidents to happen, but if they do, we'll get that stuff and we'll put it straight into the simulator, so it's realistic. And we'll use the information, just as you mentioned, Miguel, to try and improve the training all the time.
Alguém mais?
Eu aqui. I just would like to add something to Mr. Carlos. Acho que vou fazer em português a pergunta. Mr. Carlos falou que a tecnologia do SP adicionou bastante, uma nova cultura e bastante um voo mais seguro. Eu concordo com ele, mas acho que a gente ainda está numa fase de transição da tecnologia antiga para a tecnologia nova. E essa fase de transição ainda é um período que está causando uma certa confusão, até mesmo para os fabricantes. Vou citar o caso do LVV Approach do Brand New. É um sistema que no futuro vai ser muito bacana, já está funcionando muito bem lá em cima, onde o OS funciona muito bem. Mas aqui no Brasil, por exemplo, o sistema que está implantado no NIL não capta o OS. Então, a gente acabou descobrindo na prática que o sistema não estava captando o WOS e a aproximação LPV não se completava e parecia que era uma pane, mas na verdade era uma misinformation a respeito de por que não estava pegando o WOS aqui embaixo, né? Então é só para fazer assim, só para complementar que se a tecnologia não for bem aplicada e se todos os detalhes não forem bem vistos, pode ser um problema.
Yes, and obviously the WASP coverage is expanding, and I wish I was in charge of that, but I'm not. And so it's a process that we as manufacturers have to wait for that coverage. But not only do you need the WASP coverage, I mean, there are plenty of approaches in the US that are not LPV. You know, they still have to be certified, they have to be cleared, surveyed, should I say, is the correct word. So, you know, I don't know where the process is in Brazil, I just know that it's starting, and it has to start somewhere. And of course, when it starts, you really, at that higher end, the 350, the LNAV part, still a precision approach, but you know, you need the correct integrity of the system to get down to LPV. But it is coming here, because we've had this conversation a couple of years ago, there wouldn't have been any GPS approaches probably. So we are getting there, and the pilot community here in Brazil just need to really push the ATC. If you want these type of routes, then you just got to really, you guys are the ones that have to work at trying to get the authority. Unfortunately, the aircraft is capable of doing it, but it needs the correct integrity back from the GPS system. Else, it's a safety factor. That's the answer. It's not letting you do the approach because it doesn't believe the information that it's getting is good enough for it to descend, so it won't descend, which is actually a safety point of the system. It doesn't get RMP 0.3, or it's not getting the correct integration from the GPS that it's looking at, then it won't let you do the approach. So you could look at it being, it's not letting you do it because it doesn't want you to do it incorrectly or unsafely until the system's fully in place. So we have to work at, we keep working within the company, but you know, the community and the countries have to keep implementing the systems.
Ok, vamos sempre lembrar que eventuais questões sempre podem ser encaminhadas depois para a AWPC, que a AWPC encaminhá-las lá para quem de direito, quem de respeito, para que possa responder. Vamos entender dessa forma. Alguém mais?
Marcos Zotti, é meu nome, mais uma questão por gentileza. Eu gostaria, eu venho acompanhando essa inovação e os helicópteros muito sofisticados, com muitos equipamentos, e é fantástico isso. Agora, eu queria questionar o seguinte, o porquê que as fábricas não colocaram até agora as panes, as emergências dentro de um painel desse para que seja visualizada e a correção seja feita mais rápida. Hoje ainda nós trabalhamos com manual a bordo, manual de emergência. Por que não num touchscreen, numa tela dessa?
Well, I just said, if you remember from my brief, that the AW139, and I believe I'm correct in saying the 169 too, if you have an emergency, it comes with the touchscreen. I actually mentioned that. It comes with the touchscreen. So say you're on a map page. The map page is up and you have a hydraulic high temperature. The hydraulic tab will illuminate and it won't change to that page. And some people say, well, why doesn't it change to that page? Well, you might be an important part of flight. And the last thing you want is the change, right just before you're about to fly ILS and you're looking at the instruments because you're in cloud, and an emergency comes up and it takes that display away from you and puts high temperature in hydraulics, which you don't want to see. So we're away from that, but what we have done in our latest helicopters, and kind of answers the question about the SP. Yes, the SP is a few years old now. If you look at the new wave of 169, 189, and you look at how the advances are there, they're tremendous. But the 189 will put that tab up, it will tell you in this instance that you have a hydraulic emergency, and when you're ready for it, you can push the button, and then you will be able to see in front of you that display. And for sure, we're going to develop that into bringing up the actual emergency checklist as well. Some aircraft don't have enough space to have all of that information. You still need certain things to work on, but the latest wave do highlight that page so you can actually see what the problem is, see what the emergency is readily by pushing a button. And we've taken away things like the ECLs and clutter, and you know, we now have electronic circuit breakers. The advances are really moving along pretty quickly, but we need to keep them in check. You know, we need to make sure that we stay controlled in moving forward. We don't go ahead before we can. Imagine the guy in World War I who said, "Why don't you jump in that airplane? I've got a new plan. I fire the machine gun through the middle, and you'll be all right. I've timed it. The bullets will go straight through." Off you go and check it. We're a bit past that type of technology. We tend to slow down and make sure that we get it right.